Hi, this is Todd with Land of Math. In this video, we're looking at the Box and Whisker plot. And we're going to go through this video and look at three different sections. First, we're going to look at what are all the different parts of the Box and Whisker plot. The second section, we're going to look at how can you actually make a Box and Whisker plot. And there's actually four different situations that occur, so we'll dive into that. And then finally, we're going to talk about how can you read and interpret a Box and Whisker plot, and even compare two Box and Whisker plots with each other. So all that's coming up next on the Land of Math. When we're looking at the parts of a Box and Whisker, one of the key and probably most overlooked parts is the number line. It's important to pick and select the same and consistent interval. In this case, I'm going by 5s. You can also go by 10s or other numbers as well. It's also important to make sure your number line includes the smallest and the largest number of the set of numbers. Now, if it's a Box and Whisker, there must be a box, and sure enough, there it is. Now, extending out from the box are these two lines referred to as the whiskers. I didn't name this Box and Whisker graph, probably some guy named Chuck did. But on the end of each of these whiskers are little points. These are referred to as the extremes. We have the lower and we have the upper extreme. The lower extreme is the smallest number in the set of numbers, and the upper extreme is the largest or biggest number. To the left side of the box, we have what we call the lower quartile, which is the median of the smallest numbers. And on the right side of the box is the upper quartile, or the median of the largest numbers in the set of numbers. The line inside the box represents the actual median of all the numbers. Now, a Box and Whisker is broken into four sections: the two whiskers and the two parts of the box. Each of them represent 25% of all the numbers in the set of numbers. Now, if you're looking at the distance from one side of the box to another side, this is called the Inner Quartile Range. It represents the middle 50% of all the numbers. And if we look at the distance between the smallest number and the largest number, that's the range. When making a Box and Whisker plot, there's actually four different situations that can come up. The one we're going to look at first is actually probably the easiest of those four to make. So situation one, we have an odd amount of numbers, and each of our quartiles is going to have an odd amount. So step one is to find the extremes. That's the smallest and the biggest numbers. So in this case, it's the 6 and the 18. Now, we have 7 numbers in odd amounts. So we're going to have exactly one number in the middle. So you can see it's the 12 right here. That's our median of the whole set of numbers. The next thing we're going to do is find the median of the largest numbers, or the upper quartile. So you can see how 13 is right in the middle here. And that's kind of easy because it's just 3 numbers. Same thing here on the lower quartile. Find the median of the small numbers, which is 8. Once we've done that, we're now going to go ahead and make our number line. So we start off with a nice straight line. And we want to try and make the intervals, again, the same. So in this one right here, we're just trying to space it out. We're going to go by 2s. I want to make sure that I have numbers at least less than 6 and probably greater than 18. So you can see I went up to from 0 to 24 here. So when we go to make this, I like to put the extremes down first. So I put a dot where the 6 is, and we'll put a dot where the 18 is. I kind of like to do that because I know everything is going to fit in between these 2 points. Next, I like to put the 12, or the median. So I like to put a little dot and put a line through it when I do this. So now we need to plot the lower extreme and the upper extreme. So we'll do the same thing that we did for the median, except we're going to do it for the 8 for the lower quartile. And for the 13, we'll put a dot and a little line right there. Now you don't need to do the dot. I just kind of like to do it. I think it makes it easier to stay organized. Now we just actually connect all the dots here in the top of the box and the bottom of the box. And you see we have ourselves a Box and Whisker here. Situation number 2, we still have an odd amount of numbers, but now it's going to be an even amount in the quartiles. So again, step 1, let's find the extremes. So you can see we got 9 and 35 are the smallest. In this one, we have a total of 9 numbers. So again, we're going to have exactly one in the middle, which is the 25, which is our median. But now when we go to find the median of the largest numbers, we have 2 in the middle. So we add those 2 together, we divide by 2, and we get 28. So our upper quartile is going to be 28. The same thing is going to happen on the right side, or the smaller numbers. There's going to be 2 numbers in the middle. We add them up, divide by 2, and we end up getting our lower quartile, or the median of the smallest numbers. So once we've done that, it's back to make our number line. Again, make sure your intervals are the same. In this case, we're going by 5s. We went from 0 to 40, so that way we include all the numbers in our list of numbers. We like to start with the extremes, so I'll put a dot where the 9 is and the 35. And again, everything is between those two. We'll put our median. So again, I like to do the dot. You don't have to. And now I'm going to do the 2 quartiles. So we'll do 19, which is the median or the lower quartile, like the median of the smallest numbers. And then we'll find the median of the largest numbers or the upper quartile, which will be like the right of our box. So we'll put a little dot there, put a little line. And now we'll just go ahead and connect everything together. So connect the top and bottom of the box and connect the box with our extremes. And there's our box and whisker for that one. All right, situation number 3. We have an even amount of numbers, in this case 10, but when we go to find our quartiles, we're going to have an odd amount. So as always, the first thing I like to do is find the extremes, which you can see is 64 and 94. To find the median, we have to find the 2 middle numbers. So it's going to be the 5th and 6th numbers, so 73 and 79. Add those 2 numbers up, divide by 2, we get 76. So that's going to be the median of this set of numbers. Now, this is the number one spot where people make mistakes. What we're going to do with these 2 numbers in the middle, we're going to split them. And we're going to include each of those with the different quartiles. So I'm including the 73 with the smaller numbers. So there's 5 numbers here, not 4. So 68 would be the median or the lower quartile. 81 is going to be the median of the bigger numbers or the upper quartile. So now we go and do what we've been doing. So make our number line. Intervals, in this case, we're kind of going by 10s, but we're going to kind of split these in half. So even though I'm not putting 85 and 95, we're actually going by 5s. So plot the extremes, plot the median. So there's our 76. Next, we want to plot the quartiles. So we got 68 and, of course, 81. And then probably the best part is when we actually get to connect all the dots. So you go ahead and put the top and bottom on your box, connect the box to the extremes, and you have yourself a box and whisker. In our 4th situation, we have an even amount of numbers. In this case, it's going to be 12. And then we find our quartiles, it's going to be an even amount of numbers. So as always, step 1, let's find those extremes. Step 2, let's find the median. Now again, there's 2 numbers in the middle, 70 and 72. Let's add them up, divide by 2, and you get the 71. Make sure you split that 70 and 72 and use those. So on the right side, the bigger numbers, we have 6 numbers. So the same thing, we have to add up the 2 medians, the 79 and 80, to get 79.5. On the left side, we have the 55 and 63 in the middle. Add them up, divide, you get 59. So now we know all our different parts. We got our number line. We go ahead and make our intervals. You can see I started with 40 and went up to 100 just to make sure I included all the numbers. All right, so you can see we're going to plot our extremes. We're going to plot the median, which is 71. Plot our lower quartile of 59. Plot the upper quartile of 79.5. Obviously, we're just estimating the best we can. Put the top and bottom on the box. Connect the extremes with the box. And there's our box and whisker. One of the most important parts of the box and whisker is being able to read and understand it. So let's say, for example, we have this box and whisker, and maybe this is the number of tacos students in my class ate last week. There's a lot of information we can get from this. For example, I can see that the smallest amount of tacos was 6. I can also see the largest amount was 19. The median, or the middle one, was 12. I can see that the inner quartile range, which represents the middle 50% of students, has a range of 5, between 8 and 13. I can see that 25% of all the students had 13 or more tacos. I can see that 75% had 13 or less. I can also see that 50% had 12 or more, 50% had 12 or less. I can also see that 75% of the students had at least 8 tacos and 25% less than that. I can see 100% of all the kids had at least 6 tacos. 0% had less than 6 tacos. I can also see that 0% had more than 19 tacos, where 100% had less than 19. Another thing we can do is compare the inner quartile range, which is the middle 50%, with the range between the upper quartile and upper extreme. So even though the inner quartile range represents 50%, its range is less, which means the numbers are grouped together closer. We can also look at the two whiskers, and we can see the whisker between the upper extreme and upper quartile is 3 times larger, which means there's a greater range. We can even look at the inner quartile range, the box itself, and we can see that the right side is actually a smaller section. And what that means is that part of the box has a greater concentration of students. It's also great to compare box and whisker plots. You can get a lot of information this way. So let's say we had test scores of 2 classes, class A and B, and we want to make an argument for both classes. So if we look at class A, we got a lot of good information here. First of all, if we just compare their medians straight up, so the middle score was 70 versus 60, so that makes class A look a little bit better. And we can also check out the quartiles. The upper quartile was stronger, 80 versus 70, so that's your top 25% of your kids. The lower quartile was 60 versus 50. This would represent your top 75% of the kids. Now, both of them had the same inner quartile range, but you can see how class A's inner quartile range is a little bit further to the right, which means those are higher. Where you really get a good bang for your buck is looking at some other stuff. If we look at, for example, the score of 70, for class A, 50% of the people had a 70 or above, but class B only had 25%. That's double the amount. If we look at, say, the score 60, which is kind of like a passing score, 75% of class A had a 60 or above, but only 50% of class B. So all those look really good for class A. So if you're class B, what could you possibly argue? Well, for them, it would have to be the extremes. They don't have a lot of options here. If you look at the upper extreme for class B is 100, but for class A, it's only 90. So it's 10% better for their best student. If you look at the worst students, the lower extreme, the worst student in class B only had a 40, where A was all the way down to 10. Well, we hope the video was helpful. We'd love it if you give it a thumbs up and subscribe to the channel. Until next time, we'll see you on the land of math.